Hello all, I am Dr. M. Laxmidevi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. In this video lecture, we will learn about arrays in C. So in arrays, we will discuss about single dimensional array declaration, initialization, and how to access the elements of an array. So coming to the introduction, till now we have seen, so here in this video lecture, we will discuss about the concept of arrays, and then how to declare an array, how to initialize an array, and how to access the elements of an array. Now, why does this concept of array comes into picture, or where we can use this concept of arrays? So, in general, till now we have seen, or so far we have seen, there are variables. So, these variables, or these are normal variables which are used to store single data value. Now, concept of arrays is to store multiple data, or multiple data can be stored in a single variable. So that is the concept of array. Now why we need to store multiple data in a single variable, or what is the need and necessity? So when we need to work on collection of data which are related to each other, and we need to perform some operations, then we use the concept of arrays. So suppose in a class there are only 2 students or 10 students are there. So for storing the marks of 10 students, we can declare 10 integer variables like int a or student 1, student 2, etc. Up to 10 we can declare and store the marks of each student in the respective variable. So S1, S2 and so on up to S10. But the problem with this is, so if the number of students are increasing, so if the number of students are more, if they are more than 10, then it becomes infeasible, or the program becomes lengthy to declare, because there we have to declare 1000 students if there are 1000 students in a class. So suppose if 1000 student marks are to be stored, so this will require 1000 variables of that particular data type, which are to be 1000 variables of int data type to be declared. So with this, the program will become lengthy, and also it becomes tedious also. So to avoid this, we use the arrays. So when there is a need to declare when there is a need to use many variables of the same type, then we use the concept of arrays. Now with this single line, we can declare an array. You can see here. So this is the name of the array, and inside the square brackets, we write the number of elements or number of data values to be stored in the array. So when we need to work on, so this is how we can access each student marks in an array with the help of arrays. So these 1000, when we declare an array of this type with this size, so 1000 as the size of this array, so this will reserve 1000 continuous memory locations for storing these 1000 student marks. So let us see the declaration first, and then we'll see the details of arrays. First, we'll see the definition. So this is how we can define an array. So array is collection of elements of the same type, so which are referenced by a common name. So array definition is, it is a collection of data, or you can say multiple data can be stored in array. Multiple data, then data type is same. So all the elements which are there in the array, they belong to the same data type, or homogeneous, or you can say that it is a collection of homogeneous data. And coming to the storage, they are stored in continuous memory locations. So they occupy each element or each data of the array. So they occupy continuous memory locations. So compared to the basic data type, so it is a derived data type. So we can classify the type of data which array belongs to as derived data type. All the elements of an array, they occupy a set of continuous memory locations. Now let us see the array declaration. So single or one-dimensional array declaration. So this is the syntax. So in the syntax we have the data type, and then followed by the name of the array. So here name is nothing but the name of the array, and then inside the square brackets we mention the size. So here size refers to the number of data values. So based upon this size which we are declaring in this array, in the syntax, so memory location will be allocated to the array elements. So suppose for example, So in this way we declare. So first data type here is int, and the name of the array is A, and then here in the subscript, so based upon this, this is called as single dimensional or one dimensional array. So why? Because we have used here only one subscript. So based upon the number of subscripts which we are using here, so array can be 2-dimensional or 3-dimensional or 4-dimensional and so on. So more than one dimensional, we refer it as multi-dimensional array. So here A is the name of the array, and there are 5 elements to be stored in the array. All the elements of the array, they refer by the same name A, and all the elements, they belong to the same data type, that is integer. So in this way we can represent the array elements. So this is the name of the array, and then so with this declaration the compiler will allocate 5 memory locations, 1, 2, 3, 4 and 5. So 5 locations are allocated to the 5 elements of this 5 elements of the array. So it tells the compiler that A is an integer type. So A, the array will hold integer type. So this is an integer type of an array, and its size is 5 integers. So maximum elements it can store is 5. The compiler will reserve 4 bytes of memory for each integer array element. That is 20 bytes are reserved for storing 5 integers in the memory. So each element is integer type. So integer type will require 4 bytes of memory. So total memory is required is 20 bytes. So in this way, based upon this size, the compiler will allocate the memory to the array elements. Next, this is another example. So here the data type is char, so character data type, and then A is the name of the array, then 10 is the size of the array. So here size of the array, so here the compiler will allocate with this declaration, the name of the array is A and the size is 10. So maximum elements which can be stored are 10. So it tells the compiler that A is character data type of an array and its size is 10. So compiler will reserve 1 byte of memory for each character element, array element, that is 10 bytes are reserved for storing 10 characters in the memory. So for each character 1 byte is required. So therefore if there are 10 characters, so here in the size we have mentioned 10. So 10 characters can be stored here. So 10 into 1. So memory required for 1 character. So this is equal to 10. So 10 bytes are required for this array. So in this way, based upon the subscript or size of the array, the memory is allocated for the array. So these are some valid and invalid array declarations. So in the declaration, so this cannot be, the size cannot be a negative integer, or it cannot be a negative number, and it should not also be left blank. So this is invalid declaration. So size of the array should be a constant, or constant expression it should be. So these are valid declarations. So int 2 plus 2. So here you should have the name also, int a of 2 plus 2. So next int a of 2 into 3. So these are valid declarations. So this is valid and this one is valid. Why? Because this evaluates to an integer constant. So 2 plus 2, 4, and this evaluates to on integer constant. 2 into 3 is 6. So here 4 elements can be stored in this array, and here 6 elements can be stored. So or they belong to integer type. Next, array declaration. We can declare the size of the array by using macros and by using the constant keyword also. So that is, let us see what is macro first. So using macros we can declare the size of the array. So a macro is a piece of code in a program, so that is replaced by the value of the macro. So in the first video lecture where we have discussed the basic structure of a C program, so there we have discussed the different sections of the program. So after including the this header files, so below that we also write the preprocessor directives. So this is a macro which starts with #define. Macro is defined by #define directive. So whenever a macro name is encountered by the compiler, so it replaces the name with the definition of the macro. So let us see with the help of example. So here this is an example. So using macros, we can declare the maximum size of the array. So this is static declaration. Once the size of the array has been declared, we cannot change it. So therefore, we need to define maximum value. So hash using macros, we can define the size in this way. Hash define, then n is the name of the macro and the substitute here is 20. So wherever the macro name is there, wherever n value will be, wherever n is defined, so there 20 will be replaced. So that is what given here. Whenever a macro name is encountered by the compiler, it replaces the name with the definition of the macro. Here this is the name and this one is the definition of the macro. So inside the int main function, so this is how we can define the size of the, we can declare the size of the array using this macro. Next one is by using the constant variable also we can declare the size of the array. So inside the main function, we can use the constant qualifier also along with the data type. So constant int n is equal to 20. After that we need to declare the array. So here n will be equal to 20. So size of the array will be equal to 20 here. So in this way we can declare the array size, or array can be declared using macros and the constant variable. Next is how to access each element of an array. So as we know that array is nothing but a collection of data. So array has collection of data. So all the data are homogeneous type. That means they belong to the same data type, and they are placed continuously in the, or they occupy consecutive memory locations in the program. They occupy continuous memory locations. So how to access each elements of an array? So we can, in order to access each element of the array, so we need to specify the name of the array first. So name of the array, we have seen int a of 5 means here name of the array is a. So and then after that index or relative position of the element in the array. So here index is, so for the first element the index is 0. For the next element index is 1, 2, 3, 4 and 5 and so on. So here first element, so index of an array starts from 0. So 0 to the maximum value. So consider for example this example. So int x of 5. So int x of 5 means here x is an array. The size of the array is 5 and all the elements they belong to the same data type, that is integer. So this is how we can represent the array. So 5 is the size of the array. Size of the array means, so index starts with 0. So 0, 1, 2, 3, 4. So 5 elements can be stored in this array. 1, 2, 3, 4 and 5. So these are the 5 elements. 2, 6, 20, 29 and 13. So these are the 5 elements. Now let us see how can we access the elements in the array. So we can access the elements of the array by using the index. So by using the index and also the name of the array. So first element in the array can be accessed by the name of the array, and inside this brackets, inside the square brackets, we need to specify the index. So first element can be accessed by the index 0. So x of 0 means first element. So x of 0 is equal to, so in order to access the first element, we need to specify the name of the array, and then after that inside the square brackets the position of the, or the index of the array. So index starts from 0. So in order to access the second element, so here the index, corresponding index is 1. So therefore x of n, when we say x of n, so that indicates 6 is the element in that second position. So in the third position, x of 2. So in order to access this element, x of 2 is, we need to write this way. So x of 2 is equal to 20 here. So x of 3 is 29 and x of 4 is equal to 13. So first element of the array x can be accessed as x of 0, second element x of 1, third element x of 2, x of 3 and x of 4. So in this way, so array index must evaluate to an integer between 0 and n minus 1. So 0 and n minus 1 means the first element can be accessed by x of 0 and the last element of the array can be accessed by n minus 1. So x of n minus 1, where n is the size of the array, maximum size of the array. So if n is equal to 5 here, then x of n minus 1 refers to as 5 minus 1, 4. So this is the last element of the array. So coming to our program example, which we have seen. So in order to store 1000 student marks, so we need to declare an array with the size 1000. So all the marks are of integer type. So therefore the data type which is taken is integer. Name of the array is student marks and size of the array is 1000. So with this declaration, what the compiler will do is, so it will reserve 1000 contiguous memory locations for storing 1000 student marks. So the bytes allocated for this array will be 1000 into 4. So this 4 is the memory required or space required for each integer element or data value. So this 4 is depending on this is platform dependent. So in some it is 2 bytes or in some systems it is 4 bytes. So that depends upon the architecture of the machine. So generally it is 4 bytes. So 1000 into 4 is 4000. So with this array declaration, 4000 bytes will be allocated for this array. So this is how we can access each student marks. Suppose the first student has 43 marks, next student has 23 and then 56. So each student marks can be accessed by using this index. So these are first student marks can be accessed by student marks, name of the array, and then inside the square brackets, the position index is 0. So first student marks can be accessed by the index 0. So this is how we can represent it. So 0 to the name of the array, student marks, then 0. So this is the first element. Next element, student marks of 1, and so on up to the last element can be accessed by student marks 99. So last element is equal to the name of the array. Last element index is n minus 1. So if n is equal to 1000 here, so n minus 1 is equal to 999. So in this way. Now let us see how to initialize the array. So an array can be initialized at the time of declaration itself. So array can be initialized two ways. First one is static initialization and the next one is dynamic initialization or runtime initialization you can say. So static initialization means, so when the array is declared, that time itself we can give the values. So for syntax for this is, so this is static initialization. So first is data type, then array name, and then inside the square brackets we need to mention the size. So this is equal to, inside the curly braces we need to write the list of values separated by commas. So this is first example. So this is an array declaration and initialization also. So we have declared the array, at the same time we have initialized the values also. So what we are doing here is, we are declaring an array A of integer type and the size of the array is 7. So memory allocated for this is 7 into 4. 7 4 is 28 bytes are allocated for this. So each element in the array can be accessed by the index. So name of the array and then index. So first element can be accessed by A of 0, A of 1, then A of 2 and so on. The last element is A of, so 7 minus 1 is 6. So A of 6 and so on. So first element is 1, 2, 3, 4, 5, 6 and 7. So in this way we can visualize this. Next one is float. So float, the data type of this array A is float type. So therefore all the elements, so each element of the array will be of float type. So there are 5 elements in the array. Next one is, so this is another way of initializing an array. So here we have not given the size of the array. Inside the square brackets it is blank. After that we have initialized the values. So 2, 3, 4, 5 and 6. So with this what the compiler will do is, the compiler will automatically create an array, so which is big enough to hold all the values which we have initialized here. So with this the compiler will automatically create memory space here. So when we initialize the array in this way, without giving the size of the array, so here name of the array is A. So 0th position 2, first position 3, then second position we have 4, next to 5, 6 and 7. So 2, 3, 4 and 5. So here 6 will be the size of the array. So this size of the array will be determined by the compiler automatically. Next array type, next initialization is by specifying each element. So here with this example, if we have an array int a of 2. So a of 2 means maximum elements it can hold is 2. So a of 0 and a of 1. So we can initialize the value of the array by using assignment operator. So a of 0 is equal to 10 and a of 1 is equal to 20. So here this is 10 and this one is 20. So this is a lengthy process where we need to specify each index, each element and assign its value by using assignment operator. Next one is runtime initialization or dynamic initialization of the array. So during execution of the program, we can initialize the array values. So this is how we can do. So since the array is nothing but collection of data. So therefore, in order to input the values into the array, so what we do is we use the for loop. So along with the scanf function, we use the for loop. So let us illustrate it with the help of a program. Next, another way of static initialization is, so this is how, if we specify the size here is specified as 5, but we have initialized the values as 1, 2 and 3. So what the compiler will do is, so first element is 1, second element is 2, third element is 3 and the last element is, remaining elements in the array are filled by 0. So remaining elements are filled by 0 here. So if we initialize less number of values and the size is more, then the remaining elements or remaining values are filled by 0. So first 1, 2, 3, 0, 1, 2, 3, 4. So remaining values are filled by 0. Now if you initialize in this way, a of 10 is equal to 0. Int a of 10 is equal to 0. Inside the curly braces, we have given only one value, 0. That means all the array elements are filled by the value 0. Now if you initialize the array in this way, we mention the size as 5 and if you give more number of values, so here 10 values are given in the array or 10 data are given. So the array size is not enough to hold to all the array values. So this will give an error or warning will be given. So warning excess elements in array initializer. Next type of initialization is designated initialization. So designated initialization is, suppose all the elements are filled by 0 and if we need to specify only 1 or 2 values, then for that we can use designated initialization. So this is how we can use designated initialization. Suppose the array a of 5 is equal to 1, 0, 0, 0 and then last one is, so a of 1, a of 2, a of 3 and then a of 4. So this is how we can initialize the array. So 0 mentioned inside the curly braces, then inside this we need to specify the index inside this inside the brackets. So 0 will be equal to 1. That means at the 0th index value of 1 is there and at the 4th index we have 6. So 4th index means here 6 is there. So example for this is, we can also initialize the array by using this method. So this is called as designated initialization. So in this, here at the third position or the third index, so if the size is not mentioned here, the compiler will automatically decide the size based upon this, based upon the index here. So 8 is the index here. So maximum, the size of the array is reduced from the largest designator in the list. So these designators, so these are called as designators. So these are non-negative integers and size of the array is reduced or size of the array is derived from the largest designator in the list. So largest designator here is 8. So size of the array will be 9 here. So in this way we can use this method also. So if only few of the spaces or few of the index elements are there, remaining all the values are 0. Next one is runtime initialization. So runtime initialization means during runtime we can give input to the array. So here by using scanf function we can use scanf function. So along with the for loop. So this is how we can initialize the array during runtime. So here, let us see with the help of one program. So first is we have to include the this library .h file, that is header files. Then after that, inside the main function, so we have declared an array. So this is a single dimensional array. There is only one subscript and the size of the array is 3. So size of the array is 3 means first element can be accessed by 0, second element by 1, third element by, so maximum number of elements are 3, which can be stored in the array is 3. So index positions are, so index is 0, 1, 2. So we can use scanf function along with for loop. So for I is equal to 0, so when we use for I is equal to 0, so we are using this for loop to initialize the value of array, to initialize the array. So for I is equal to 0, starting index is 0, so therefore I is equal to 0. The condition to be checked is I should be less than 3. So it should be less than 3. The maximum size of the array, or the maximum size of the array is, or maximum elements it can hold is 3. So therefore I less than 3. Then after that I plus plus, I value has to be incremented. So when I is equal to 0, scanf function %d, since it is the arrays of an integer type, so we use %d as the format specifier, then comma, at this address specified by a of I. So a of I means starting will be a of 0. So at the address specified by the variable a of 0, the corresponding value will be stored. Next, I value will be incremented by 1. So 1 is less than 3. So this condition is true. So initially also it will check the condition 0 less than 3. So this condition is true. So therefore this value will be taken. And then after that 1 is less than 3. So this value is, this condition is true. Then after that the other value of, so ampersand a of 1. So this value we can initialize. Then I value will be incremented by 2 by 1. So I value is equal to 2, 2 less than 3. So this is true. So with this ampersand a of 2. So this value will be, suppose the user is giving 10 here. So a of 0 at the address specified by a of 0. So these values are to be stored. Suppose 10, 20 and 30. A of 0 is 10. So a of 1 is 20 and a of 2 is 30. So in this way, by using for loop and scanf function, so runtime array initialization can be done. So we can similarly print the array elements by using printf function. So inside the for loop, so this for loop, so it has to be 3 elements are there. So we need, if we don't use any for loop, so 3 printf functions are required. So printf %d a of 0, then after that printf, so similarly, so after that the next element is a of 1, then printf, the next element is a of 2. So in this way 3 printf functions are required. So when we need to repeat the same piece of code again and again multiple times, so there we use loops. So that is why this concept of loop comes into picture along for printing the values of array here. So in order to print the value of the array, we first starting position must be initialized and the last element also should be mentioned. So in order for this is a for loop. For j is equal to 0, j less than 3, j plus plus. Inside the for loop, printf function is there. So this printf function will print all the values of the array. So that is 10, 20 and 30. So in this way, so for this, if we run this program, this is the output. So enter the array elements. So in the next line we can enter. So each element of the array a of 0 is equal to, so at the address specified by a of 0, 10 value is stored. At the address specified by a of 1, value of 20 is stored. At the address specified by a of 2, the value of 30 is stored. Then after that we are printing the values of array. So at the corresponding indices, so a of 0 is 10, a of 2 is, a of 1 is 20, a of 2 is 30. So in this way, next one, how these arrays are represented in the memory. So array representation. So let us illustrate how the arrays are stored in the memory. So we have seen that each of the array element, they are stored continuously. or they occupy consecutive memory locations. So let us see with the help of one program. So here we have an array int a of 3. So maximum size of the array is 3. There are 3 elements which can be stored. The first element position or index is 0. So a of 0, next is a of 1, after that a of 2. So 10, 20 and 30. So these are the elements. So this is static initialization. So during declaration itself, so at the time of declaration, values have been initialized to the array. Now next, in order to iterate over the loop, so we have taken a variable I. So that is also an integer type variable. So here for loop, we have used for loop. So for I is equal to 0, I less than 3. So starting value I is equal to 0. So 1 is less than 3. This condition is true. So when this condition is true, the line which is, or the statements which are there inside the for loop. So if there are no braces here, you can see here, if there are no brackets, only one statement will be executed in the for loop. So this statement will be executed. So this is the statement which is executed. So here percentage %d, corresponding value is I. So that is I is equal to 0, a of 0 is equal to. So this gives the address of the array element. So first element, address of the array element. So this percentage %u is for ampersand a of I. So ampersand means it gives the address. So here you can see ampersand a of 0 is equal to, this is the address of the first element of the array. Next, again the loop will repeat. I value will be incremented by 1. So this is what we got, 2293312. Next, I value will be incremented by 1. I is equal to 1. So here it should be 0, sorry. So I value is equal to 1. I is less than 3. So this is true. When this is true, so this will be the output. A of 1 is equal to, corresponding address will be printed here. So 2293316. Now you can see here the difference between the first element and this next element is 4 bytes. So first element starting address is, or this you can say as the base address or the starting address of the first element. Starting address of the array element you can say, or the address of the first element. Now similarly we can predict the address of the last element. Ampersand a of 2 is equal to plus 4, 2293320. So it will repeat, the loop will repeat. Now I is equal to 2 here. So 2 is less than 3. So this condition is true. So this line will be printed. Now after that, when this I value is incremented by 1, so I is equal to 3. So 3 is less than 3. This becomes false. So for loop will be terminated. So control is transferred here. So next printf statement will be executed here. So in this printf statement, what we have written is base address of the array A is the corresponding to this format specified. We have this value to be printed. So percentage %u is nothing but it will print the address. So this is format specified for unsigned integer. So when we are trying to print the value of A here, so as you can see, so we are getting the address of the, so this value and A, the value of A is 2293312 and A of 0 is also, the address of this is 2293312. So from this we can say that, so when we are trying to print the value of A, then it gives the address. So it is not giving any value, but it gives the address. So when it is giving any variable which stores the address of another variable, that is called as pointer variable. So here name of the array is nothing but it stores the address of the array. So array A is a pointer variable. So from this we can say that A is a pointer variable. So this is how you can represent the array in the memory. So here first element is 10. So this is A of 0. So next one is A of 1. Next is A of 2. So first element index is 0. Second element index is 1. And the third element index is 2. So first element is 10, 20 and 30. So we have with the help of the program. So this is what we have got. So this element is stored at this address. The next element is stored at this address. So we can calculate the address of each element by using this formula. So base address is this one, the starting address. So 2293312 plus the index. So in order to calculate the address of the second element, so index is 1 here. So 1 into size of int. Suppose size of int is 4. Then 2293312 plus 4. So this is equal to 2293316. So in this way you can calculate the address of each element. So thus from this program we have seen that the array elements, they occupy continuous memory locations, and the array name is nothing but a pointer variable because it stores the address of the array. Next one is one more program we can see. Program to print the elements of an array in reverse order. So let us see this program. So this is nothing but, suppose we have an array. So name of the array is A. So we have 1, 2, 3, 4 and 5. So these are the elements. So for these elements, so program, the output expected is just the way we access A of 0, A of 1, A of 2, A of 3 and this one is A of 4. So program to print the elements of an array in reverse order. Just we are printing or we are accessing the elements in the reverse order. That means first we are printing the value of this. So A of 4 is equal to 5. Then after that we need to print 5, 4, 3, 2 and 1. So this is what the program means. Just to access the elements in reverse order and print them accordingly. So this is the function for that. So this is the array we have declared. A of 100. So here 100 is the maximum, this is the size of the array. So we have declared the size as 100. That means maximum elements which can be stored in the array is 100. Then I is the variable, integer variable. N is also an integer variable. Next to printf statement, how many numbers to be read. So that will be printed. So by using scanf function, this value of n is equal to, so n is, this value of 3 is stored whatever the user is giving. So this value is stored at the address specified by n. So n is a variable, integer variable. It will have some address. Suppose that address is 1000. So at that address, 3 value is given. So this is the value given by the user. So this value will be stored at the address specified by n. Next to for loop. So we need to initialize them. So we need to access, first this is runtime initialization of the array. So first we need to initialize the array elements. So for loop has to be written. So for I is equal to 0, the condition to be checked is for I less than n. So here the size of the array is given as 3. So I less than 3 means, so till, so it will repeat for 3 iterations. So I is equal to 0, I is equal to 1 and I is equal to 2. So loop will repeat 3 times. So 3 elements can be inserted. 3 elements can be taken into the array by using the scanf function. So %d, each element value can be read, or this is the statement to read elements into the, to read values into the array. So A of I, suppose we are giving A of I is equal to 10, 20 and 30. So this is the array. Since the size of the array is 3, first element is 10, next element is 20, next element is 30. Now in order to access the elements in the reverse order, so what we do is, this is the 0th position. So this is A of 0, this is A of 1, this is A of 2. So in order to print the elements in reverse order, so just start from this index position. So start the last element, in order to access the last element. So in order to print the elements in reverse order, first we are accessing this element. So for loop will iterate from. So this loop also has to be repeated for 3 times, and but the starting value is this index. So for I is equal to n minus 1. So n minus 1 here. So n is equal to 3 we have given. So n minus 1 means 2. Then after that, the condition to be specified or to be checked here is I greater than or equal to 0. After that, I minus minus. So I value has to be decremented. First it should start with 2. Then the index value is 1. After that the index is 0. Then inside this we need to write the printf statement. So in the printf we are printing the value of each array element. So %d and then A of corresponding index. So when we are writing this, so the elements in the reverse order will be printed. So I is equal to n minus 1, that means 2. A of 2 will be printed first. A of 2 is equal to 30. Next I value will be decremented. So decremented means I is equal to 1 now. So when I is equal to 1, so that will be printed at this particular location, or at this index 20 is there, so 20 will be printed. So after that I value is decremented, so it will check the condition 0 is equal to 0, that becomes true, and then value of 10 also will be printed. So in this way we can print the elements in reverse order. So we are not changing the sequence here, just we are reversing the elements. So this is just a program to print the elements of an array in reverse order. So these are some of the disadvantages of an array. So once size has been declared, so it cannot be changed during runtime. So that is the main disadvantage of this array. No bound checking. So we have seen no bound checking means, so even if the array size is declared as that we will see with the help of one example. So in C, while accessing array elements, array bounds are not checked. So array bounds are not checked means, suppose we have declared an array of size 3. So size 3 means maximum elements it can store is 3. Now if you try to write this, and if we try to access this element a of 4, so it will not give an error. So it will not give error, program will not give an error. So this, it will be compiled, but it may produce unexpected output. So output can be unexpected. So therefore there is no provision in the program. The programmer has to check for the bounds, or he or she has to check the size of this array and write the program accordingly. So this is one more program to copy the elements of an array to another array. Now let us see. So there is one array, so where you have some values. So 3, 6, suppose these are the values 3, 6, 1, 7 and 8. So a of 0 is 3, a of 1 is 6, a of 2 is 1, a of 3 is 7 and a of 4 is 8. So what we have to do is, this is a program to copy the elements of an array to another array. So we have to declare one more array. So this array can be, its size should be the same as this array, or its size can be greater than this array. So let the size of this array also be, its size also should be the same. So suppose we have to declare another array B, and we have to store the contents of all this data has to be stored here also, has to be copied to this array. So 3, 6. So this is, in order to do this, so what we have to do is, first we have to declare the array A with size 5. So we are declaring one more array B with the same size 5 and one more variable I. So printf statement is written, enter the numbers, then this loop will repeat 5 times. So from I is equal to 0 to 0, 1, 2, 3, 4. So these many times the loop will iterate here. So in the iteration, and what we are doing repeatedly, we are using the scanf function. By using scanf functions, values are read into the array at the address specified by this line. So percentage D here corresponds to the value at address A of I. So A of I means at the address specified by A of 0. So A of 0, at this value, this 3 will be stored. Suppose the user is giving 3, next 6. So these are the values entered into. So this is runtime initialization of array A. So 3, 6, 1, 7 and 8. So these are the values given into the array A, or read into the array A. Next, in order to copy this array elements into another array B, so we have to use for loop again. And then along with the for loop, inside the for loop we need to use, so this is the statement, or this is the, with this statement we can assign or we can copy the values of A into B. So each value has to be copied at the corresponding index. So A of I means, so it's here A of 0 is, so this value has to be assigned to B of 0. Then A of 1 has to be assigned to B of 1. A of 2 has to be assigned to B of 2. Then A of 3 is equal to, so B of 3. Then B of 4 value is assigned the value of A of 4. So in this way, so these statements have to be done repeatedly. So instead of writing each line by line, what we are doing is we are using a for loop. So for I is equal to 0, so this is what we are using. For I is equal to 0, so this loop has to be repeated 5 times. So index value starts with 0 and the last element is 4. So that is 5 minus 1. So I less than, here you can write the condition as I less than this 5, or you can write it as I less than or equal to 4. So we have written here I less than 4, after that incrementing. So after one value is assigned, so I value has to be incremented for each in each iteration. So in the next, we have two statements inside this for loop, so therefore we are using braces. So if we don't have two statements, if there are only one statement, we can skip these braces, but these two statements are executed in the for loop, therefore we are using these braces here. So in the printf statement, so this will be the value which is to be printed. So b of percentage d. So b of percentage d means the index percentage d is corresponding to this value I. So I is nothing but I value is changing in each iteration. So b of 0 is equal to percentage d here corresponds to b of I, the value which is there in b of I. After assigning, so after this line, b of I has to be printed. So b of I is equal to 3, then b of 1 is equal to 6. So in this way, all the values of this array A will be copied to the array B. Next one is program to count even and odd numbers in an array. So here the program is to count odd and even numbers in an array. So we have an array where we have different all the elements of the array are of integer type. So therefore we declare an array A of integer type. The size of the array is 5. Then we have used 3 more variables. Then I, all of them belonging to integer type. Then even is equal to 0 and odd is equal to 0. So in the memory, so this is a variable where its value is assigned as 0, and in the memory we have this as a variable, its value is also assigned as 0. And this is a variable I, its value will be changing during each iteration. So initially, so when we use it, so this is used inside the loop. I variable is used inside the loop to iterate over the loop here. Now let us see what are the values of I. So first, printf enter the numbers. So this line will be printed. Then by using scanf function, so values into the array can be read. So first element read here is, so for I is equal to 0, so a of 0 is equal to, so in the scanf function we need to mention the address. So we need to use, along with format specifier, we need to use this ampersand symbol also, followed by the name of the array and in the subscript the corresponding index. So for a of I, first is when I is equal to 0, a of I means a of 0. So at this address specified by a of 0, so whatever the values user is giving, so that will be read into the array. So 23, and then I value will be incremented by 1. This condition will be checked. Now I value is equal to 1 year. So for each iteration, this I value will be changing. I value is equal to 1. Again, this scanf function, this statement will be executed. So percentage d, since integer data type has to be read into this array. So therefore, next value will be, value is stored at ampersand a of 1. So ampersand a of 1 means this, the address specified by this at this location. So at this location, another variable will be read. So in this way, I value will be incremented again. Now I value is equal to 2. So this will go on repeating. So these statements will go on repeating till I value is equal to, so suppose this is equal to 12. Last element is 12. So a of 1, a of 2, a of 3 and a of 4. So I value will be equal to 4. Last element I value 4. After that this condition becomes false and then the control is transferred here. So next for loop will be executed. So here also, in order to perform operations on arrays, so arrays we know that these are collection of data, so which belong to homogeneous data type. So all the elements in the array, they are of same data type and they are stored contiguously memory. They occupy contiguous memory locations in the program. So by using this program, by using this for loop, we can, so this is a these are the statements which are to be executed to check whether each of the number is even or odd. So to check, suppose we have int a is equal to 25. So in order to check whether this value is 20, whether this value is even or odd, what we do is this a mod 2. If this 25 divided by 2 or mod 2 is equal to 0. So if the remainder of this is 0, then it is even. If the remainder of this is, if 25 mod 2 is not equal to 0, then it is odd. So we can implement this by using simple decision making statements, that is simple if. Simple if statement, we can, if else statements, we can implement this logic to check whether the given array element is even or odd. So this process has to be repeated for 5 elements. So therefore for loop is used here. For I is equal to 0, I less than 5, I plus plus, if a of i. So each element in the array is accessed by a of, and then inside the square brackets we mention the subscript here. So a of 0, if a of I mod 2 is equal to 0, if this condition is true, the given number is even. So even count is, so even will be, so initial starting value of even is, so in the variable named even, we have initialized the value as 0. So even plus plus, that means if the given number is divisible by 2 and then it is an even number, this count will be incremented by 1. Else odd number, so odd count will be incremented by 1. So in this way we can write the logic for this. After the for loop, printf statement, even numbers is equal to percentage %d. So percentage %d is, so whatever the value is there in the even in this variable, so that will be printed. So here whatever the value of odd is there in this variable odd, so that value is printed with the help of this printf statement. Suppose these are the numbers read into the array 23, 45, 62, 78 and 12. So in order to, so here you can see that, so this first number will be checked. So this is an odd number. So odd count will be incremented by 1. Next after that, the second element will be checked. This element is also an odd number. So odd count is incremented by again 1. So previously it was 1, now 2. Next, this is an odd number. This is even number. So even count will be incremented by 1. So this is incremented by 2 here. After that, this is an even number. So this will become 2. This is even number. So this will become 3. So in this way, even count is, so even numbers are 3 and odd numbers are 2. So in this way, we can write a program to count even and odd numbers in an array. Now these are some of the disadvantages of array. Let us discuss the disadvantages. Now we have seen that the size is fixed. So array size is fixed. Whatever size we are giving at the time of declaration, so we can't exceed the limit. So even if we exceed, so we can't exceed the limit. So that is the main disadvantage of array. Whatever size is defined at the time of declaration of the array, we can't exceed the limit. Next, insertion and deletion is costly. So if, as we know that, so different elements in the, or different data values, they occupy contiguous memory locations in the array. So therefore, inserting an element and deleting an element in the array is costly because shifting operations are to be done here. So since the elements are needed to be managed in accordance with the new memory location. So insertion and deletion is costly. Now these are some of the applications of the array. Arrays are used to perform matrix operations. So various operations on matrices can be performed by using two-dimensional arrays. So we'll discuss the concept of two-dimensional arrays in the next video lecture. So two-dimensional array, there will have 2 dimensions. Arrays are used to implement search algorithm. So by using like linear search and binary search. Then arrays are used to implement sorting algorithms. So sorting, like there are different sorting algorithms: insert sort, bubble sort, selection sort, etc. So these are the sorting algorithms also can be implemented by using these arrays. Then arrays are used to implement data structures. So data structures like stack using arrays and queue using arrays. So these are some of the applications. All these applications we'll discuss in the coming video lectures. So this is all about the declaration, initialization, and how we can access each elements of the array. So in the that is also we have discussed for about single dimensional array. In the next video lecture, we'll discuss some more concepts of arrays. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.